Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter water. Okay, in the earlier sessions we have seen different concepts in the water and even about physical properties of water also we have completed. In this session we are going to say about the chemical properties of water. Okay, first if you see the nature of water, pure water is neutral towards litmus. So it is not neither an acidic or nor basic substance. It is neutral substance. Generally, acids they turn blue litmus to red color, and bases they turn red litmus to blue color. If you take these two colored litmus papers and if you test water, it won't show any color change. So that represents as water is a neutral substance. And stability. Water is a very stable compound. It does not decompose into elements when heated to ordinary temperatures. So even if you heat to higher temperatures also, water won't be decomposed because it is a stable compound. Just it converts from liquid state to a vapor state, but it won't be decomposed into respective elements. Those are hydrogen and oxygen. However, if it is heated to around 2000 degrees Celsius temperature, even at the temperature also very small quantity, around 0.6% of it decomposes to form hydrogen and oxygen. So in that way, we can say hydrogen is a stable compound. The decomposition of water is not simple. It requires high and high energy. If it is heated at a very high temperature, then also a small quantity of water, around 0.6% of water, it splits into respective element. They are hydrogen and oxygen. So this is the reaction occurs. When water decomposes or when water is heated above 2000 degrees Celsius temperature, then it splits into respective elements hydrogen and oxygen. The same can be done by electricity also. If we apply electricity into the acidilated water, then water decomposes into respective elements hydrogen and oxygen. That is a chemical process. But physically, by physical methods, we cannot decompose water simply. It requires uh, high temperatures. Even though water is heated to about 2000 degrees Celsius, then also a small around 0.6% of water only decomposes into respective elements hydrogen and oxygen. So we can say water is a stable compound. Now let us see the reaction of this water with the metals, how it reacts. First let us see the action of water with highly reactive metals. There are three categorized metals based upon the reactivity. We can say one is highly reactive metals, then reactive metals, and next least reactive metals are noble metals. Now first let us see the reaction of water with highly reactive metals. There are certain metals which react vigorously in the chemical reactions. Those we say as highly reactive metals like sodium, potassium, calcium, etc. Okay. So when a small piece of these metals is dropped into cold water, this water reacts violently to form their respective hydroxides and hydrogen gas. So these metals will react with the even cold water also vigorously. Very fast reaction occurs and they form respective metal hydroxides and liberate hydrogen gas out. See the reaction. Suppose when a small piece of sodium is dropped into cold water, immediately sodium burns and it reacts vigorously with the water and forms sodium hydroxide and hydrogen gas is liberated out. In the same way, if you see potassium, even a small piece of potassium will drop it into so water that also will react vigorously with the water and forms potassium hydroxide and liberates hydrogen gas. And calcium also in a similar way, calcium reacts with the water and forms calcium hydroxide and hydrogen gas. And in these all reactions, energy is liberated out. So we can say these reactions are exothermic reactions. I think you know what is meant by exothermic reaction. The chemical reactions in which energy is released out while reaction is occurring are called exothermic reactions. The reactions in which energy is absorbed are called endothermic reactions. But here, the reaction of highly reactive metals with water is exothermic reaction. That's why you see here in all the reactions, the liberation of energy is mentioned. Okay, that's about reaction of highly reactive metals with water. So here, action of magnesium with water or action of water on magnesium. Magnesium, if placed in cold water, does not react with it because it is somewhat less reactive than the highly reactive metals sodium, potassium, and calcium. That's why it won't react with the cold water. If you take magnesium powder is with the boiled water, means hot water, very slow reaction takes place. However, if burning magnesium is plunged into steam, it burns for few moments to produce magnesium oxide and hydrogen gas. But then the reaction stops. So as magnesium is somewhat less reactive, this won't react with the cold water. Okay, when magnesium powder is reacting with boiled water, a slow reaction takes place to form magnesium oxide. However, if burning magnesium is plunged into stream of water, then reaction occurs and then magnesium continues to burn for few seconds and produces magnesium oxide and hydrogen gas and then it stops burning. Reaction will be stopped. So this reaction occurs when burning magnesium is introduced into steam with high temperature. Then it reacts with the water steam to form magnesium oxide and hydrogen gas. Okay. Then action of reactive metals like aluminium, zinc, iron with steam. So these are somewhat less reactive metals than highly reactive metals. So we can suggest these are reactive metals. Second category we can say. These metals also they won't react with the cool water. So these will react with the high temperature steam because steam will have more temperature than normal boiling water. That's why these metals they can react only with steam. Aluminium, zinc, and iron react with steam practically the same way as magnesium. So these are also somewhat less reactive comparatively with highly reactive metals. That's why these metals they do not react with even cold water or boiled water, but they do react with steam. So these also react just like the magnesium how it does. Okay, the reaction amongst the above three metals is fastest in case of aluminium, slower in case of zinc, and the slowest in case of iron. As reactivity decreases, the reaction with the water also will be in less rate. So out of this, aluminium is being a little more reactive, so it reacts with the water faster and compared to the remaining two. And thus reaction is slowest in case of iron. So as a matter of fact, in case of iron, the reaction is reversible also. Means iron reacts with the water forms iron oxide. And this reaction is reversible also. Again, iron will be being formed back. The reaction in which chemical substances combine to form new substances. And those new substances decompose back to reform the original substances are called reversible reactions. As the reactivity of iron is less, the reaction between water and steam is reversible. Let us see the reactions involved in these. See first one, aluminium on reaction with steam means at a very high temperature. It forms aluminium oxide and hydrogen gas. In the same way, zinc also. Zinc also on reaction with the steam forms zinc oxide and hydrogen. But here the reaction of zinc with steam is somewhat slower when compared to this. This is more faster. This is a little faster than this. On the reaction of iron with steam, it also occurs at very high temperature to form iron oxide and hydrogen gas. But if the temperature is reduced, the reaction also occurs in the backward direction also. Means iron oxide reconverts into iron and steam. Such kind of reactions in which reactants converts into products, again products converts into reactants back, are called reversible reactions. So here the reaction of iron with steam is an reversible reaction, and it is somewhat slower when compared to the above two. So it is slow reaction. Okay, and water does not react when treated with metals like copper, silver, gold, and mercury, and lead, mercury. These metals are called least reactive metals. You can say they are third category in the reactivity. So least reactive metals. These metals they do not react with water or steam also. Okay, they won't react. What are those metals? Copper, silver, lead, gold, mercury. These metals they do not react with the water in any condition. Next, action of now we have seen till now action of water with the metals. Now let us see the action of water with the non-metals. How do they react here? Suppose if you see action of water with the carbon, white hot carbon reacts with the superheated steam to give water gas. So actually carbon at normal conditions it won't react with the water. But if it is red hot or very hot carbon, that we say white hot carbon, very hot carbon, it reacts with steam, superheated steam to give water gas. Water gas is a combination of carbon monoxide and hydrogen gas. So white hot carbon, very high temperature carbon reacts with the superheated steam with very high temperature. So at very high temperature, this reaction occurs. There, carbon reacts with the water to form carbon monoxide and hydrogen gas. The mixture of these two, carbon monoxide and hydrogen, is called commonly as water gas. Okay, that's a reaction with carbon. Carbon reacts with the steam at very high temperature to form carbon monoxide and hydrogen gas. The mixture of carbon monoxide and hydrogen is called as water gas. Next, action of water with chlorine. When chlorine is bubbled through water, it forms two acids. Okay, when chlorine gas is bubbled through water, it reacts with the water and forms two acids. They are hydrochloric acid HCl, hypochlorous acid HClO. So these two acids are formed when chlorine reacts with water, HCl and HClO. These two are acids which are formed when chlorine gas is bubbled through water. Okay, that's the reaction of chlorine with water. Next, action of water with metallic oxides. Yes, not only metals, even metal oxides also they do react with water. Let us see how they do it. Oxides of sodium, potassium, calcium means these are highly reactive metals you have seen, isn't it? They're oxides. That means sodium oxide, potassium oxide, and calcium oxide react with cold water to form their respective hydroxides. The reactions are exothermic in nature. As these metals are highly reactive, they react with the water with liberation of energy. Not only metals, their metal oxides also react with water with liberation of energy. They form here also their respective metal hydroxides. All other oxides are insoluble in water. They do not react with the water. Okay. See how these highly reactive metal oxides are reacting with the water. If we see sodium oxide on reaction with the water, it forms sodium hydroxide. Potassium oxide, K2O. potassium oxide on reaction with the water forming potassium hydroxide. Then calcium oxide. Calcium oxide on reaction with the water, it forms calcium hydroxide. Okay. But remaining metal oxides, they do not react with the water as they are insoluble into water. Okay. Next, action of water with non-metallic oxides. Not only metal oxides, even non-metallic oxides also they react with water. Non-metal oxides on reaction with water, on dissolving into water, they form respective acids. Okay, as metallic oxides on reaction with the water forming basic substances which are called metal hydroxides. In the similar way, non-metallic oxides on dissolving into water, they form respective acids. For example, if you see sulfur dioxide on reaction with water forms sulfurous acid it is called. So sulfur dioxide on reaction with water, on dissolving into water, it forms respective oxide called sulfurous acid. If you see sulfur trioxide, the other oxide of sulfur trioxide on dissolving into water forms sulfuric acid. Okay. And if you see another non-metallic oxide, nitrogen dioxide on dissolving into water, it forms two oxides. Majorly it forms nitric oxide and nitrous oxide. Two acids are formed when nitrogen dioxide dissolves into water. See another non-metal oxide, phosphorus pentoxide. This is a P2O5. It is called phosphorus pentoxide. This on dissolving into water, it forms a respective acid called phosphoric acid, H3PO4. Okay, next, carbon dioxide on dissolving into water, it forms a carbonic acid. Actually, this reaction occurs in the formation of drinking soda, soft drinks also. What do they do? They dissolve this carbon dioxide gas into water. Then this carbon dioxide, non-metallic carbon oxide, on dissolving into water, it forms its respective acid called carbonic acid. By the formation of this carbonic acid only, those soft drinks and soda they get some sour taste. Okay, anyhow, these non-metallic oxides on dissolving into water, they form respective acids. Okay, next. Now let us that is about the chemical properties of water. Now let us say what are the factors which are affecting the shortage of water in our daily life. Increase in the population has increased the demand of water. As population increasing, the usage of water is increased. So it is causing the shortage of water. One more factor is a change in lifestyle of people has increased the consumption of water, isn't it? More vehicles have come, so lifestyle is changed. Industries have come which are consuming more water. So by these all factors, by the change in the lifestyle of people, consumption of water is increased. And urbanization has decreased the groundwater reserves as concrete roads do not allow the seepage of water. Yes, it is one of the major factors. In the earlier days, more land will be available for sinking of this rainwater. But nowadays, what is happening? Urbanization is increased. Because of this, more concrete roads and more concrete buildings are constructed. So, because of this concrete flooring, no land is available for seeping of this rainwater. So, if the rainwater is seeps into the ground more, then groundwater level increases. There will be no shortage of water. But because of this concreting, covering the land with concrete roads and the concrete buildings, there is no way for the rainwater to seep inside the land, and hence we are facing shortage of water. Not only this, even industrial demand for water is also increasing shortage of water. Okay, they are the major causes for the shortage of water for us. Now let us see how to conserve water to avoid this shortage. How can we conserve? this water. In summers, people face shortage of water because of the level of groundwater goes down, and so there is no water in wells and tube wells, isn't it? This is you might have to observe in many places. In summer seasons, there will be no water in the wells and the tube wells. Even pumps they cannot pump the water because the groundwater will go down. If there is low rainfall, the situation becomes even more grim. The land becomes more dry. There is a scarcity of then there will be scarcity for even for drinking water also. Therefore, management of water resources is very important, and in this water conservation plays an important role. So we have to conserve the water. We have to manage the water resources to avoid this scarcity of water. That managing the water to avoid the scarcity of water is called conservation of water. So in that, the important thing is rainwater harvesting, preserving this rainwater without wasting. That is rainwater harvesting we call. Rainwater simply flows into drains and is lost. So what happens when it rains heavily? All the rainwater forms streams and finally it reaches oceans and dissolve. Without usage, it will be wasted there. It drains useless. So if it is preserved, instead, this rainwater can be collected and used later. This is called harvesting of rainwater. So instead of wasting or draining that water unnecessarily into the river, seas, and oceans, if we preserve that, if we collect that rainwater and if used for later purposes, that is called rainwater harvesting. Rainwater from rooftops and kitchen weather can be collected in the groundwater tanks. The water from these tanks percolate groundwater underground and recharges the aquifer so that the water table increases. Water table means the level of water under the ground. It increases gradually if you make this water rainwater seeps into the ground by using sink pits and underground tanks. By this all, if you make this rainwater to seep into the ground, then groundwater level increases and hence we can uh, avoid this scarcity of water. Okay, this is called rainwater harvesting, right? Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.